Hey guys, welcome back to our channel Tech Taste Tool. In this video, we're going to discuss Leetcode problem number 30, that is search in rotated sorted array. This is also the third problem that we're going to solve in binary search series. So please stay tuned till the end. Let's understand the problem statement first. You are given a sorted array which is rotated by few places. For example, you have a sorted array 6, 9, 18, etc. The first array, and then the first two elements 6 and 9 are rotated to the last. So the array which is sorted is rotated. Now you are supposed to search for an element in this rotated sorted array. Now let's see how to do that. We have this approach of linear search where we traverse through the entire array and see if our target element exists or not. But this takes O of n time complexity, which is huge. That's why we opt for binary search, which will eliminate the search space in half in every iteration. Now, this is the sorted array, which is not rotated. Now, let's see how do we do binary search. Now, the first step to do binary search is to calculate the middle element. The middle element is 18 and the target is 52. 18 is less than 52. And we already know that the array is sorted. So all the elements to the left of the array are less than 18 and all the elements to the right of the array are greater than 18. So with confidence that 52 will not lie on the left side of 18, we will remove the search space in the left half. We'll only concentrate on the right half because 52 is greater than 18. Now again we do the binary search and finally we find index 5 is 52. But what is the key point here? The key point here is we are confident to remove half of the search space only because the array is sorted. But what happens when the array is rotated like this? So just as in binary search, we also find the mid value in this array. The mid value is 47 here and the target value is 52. Now you can see that there are two parts. One is sorted part and the other is unsorted part. Because when we do rotation, the rotation is happening at one index, right? So one part will be unsorted and one part will be sorted on this. How do we decide which side, either the left subarray or the right subarray, which part to choose and which part to apply binary search on? So we know the target is 52 and we know the left pointer is 18 and we also know the mid value is 47. Now let's compare. Now left is less than mid, 18 is less than mid, 47, yes. Now comparing left and target, 18 is less than 52. So the left part is sorted. So we only concentrate on the right side. Okay. Now looking at the right part of the array, now 6 becomes the mid value, 52, 6 and 9, 6 becomes the mid value. Now when 6 becomes the mid value, the left pointer is 52, 9 is the right pointer. Now again comparing left, mid, target. Okay. Target is equal to left, so target is greater than or equal to left. Yes. Target is greater than mid. Yes. So which means the right part of the array is sorted. By eliminating right half, so we update the right pointer, concentrating on the left pointer. So right is equals to mid minus 1. So there are only two elements left. When we do again binary search, we will understand that 52 is the target. So let's write the clear approach of what we have done previously. First, just as in binary search, we take mid and we take the mid and compare with the target. If target is equals to mid, well and good, we'll return the mid. If mid is greater than or equal to left, then left half is sorted. If mid is less than left, then right half is sorted. If left half is sorted, then we compare target is greater than or equal to left and target is less than mid. Then no right half. You concentrate on left half only by updating right is equals to mid minus 1. Or if those conditions false, then we move to the right half saying that left is sorted. Left is equals to mid plus 1. Similarly, when right half is sorted and when target is less than or equal to left and target is greater than mid, then target might be in the right half, so we continue left is equals to mid plus 1. Otherwise, we move on to the left half by settling right is equals to mid minus 1. Now let's see how to do this in programming. First we have a function search where there are two parameters, that is nums array, that is the array of integers, and then the target which we are supposed to find. Then we are calculating the length of the nums array and we are initializing two pointers left and right as 0 and n minus 1. Why 0? Because in arrays, indexing starts from 0. Now we'll start the while loop. Condition of the while loop is set to left is less than or equal to right, which means right should be greater than left. Whenever right is greater than left, the while loop runs. If left is greater than right, then the while loop stops. Now here we are calculating mid as left plus right minus left by 2. You know how to do this, right? We calculate mid as left plus right minus left by 2 instead of left plus right by 2, because to overcome the overflow errors, which we have clearly in the first video of binary search. If you haven't watched it, please go and watch it. Now, the first thing we are going to do is to compare mid and target. If mid is equals to target, we will return the mid. If mid is greater than or equal to left, which means the left is sorted, then what are we going to do? We are supposed to check if target is greater than left and target is less than mid. Then we can update the right to mid minus 1, saying that the target might be on the left side of the array. Or else we'll update the left as mid plus 1, saying the target might be on the right side of the array. Similarly, if mid is less than left, which means the right array is sorted, then again we check the same things. If target is less than or equal to right and target is greater than mid, if that is the case, we understand that the target might be on the right side, so we update mid. So we update left to mid plus 1, or else we update right to mid minus 1. Once we are done with iterating the entire array, we will either return the mid, or if the element is not present, we will return minus 1. So let's understand the time and space complexities now. So the time complexity is overflowing. What are we doing here? We are just eliminating the search space in every part of the iteration. And this is as it is the binary search with the conditions different, right? We are just editing the conditions. Other than that, it's similar to binary search. So the time complexity is overflowing. We are not creating any extra spaces, any extra arrays, except creating a few variables which takes a constant space. So the space complexity is overflowing. Thank you so much for watching till the end. I hope you understood the video. Please like, share and subscribe to our channel. Get this. Thank you.